Welcome Pure Maths 1 students. We're moving on to a new section of work in our Pure Maths course, and we're going to start that with Pascal's triangle. We're talking about binomial expansion. So if you think back to your learning from IG, you'll have learnt how to expand brackets. You'll have learnt to expand something, say like x plus 5, and you square that and you know, oh well, that's going to be x squared plus 10x plus 25 or something like this. Okay. And the big question and the skill, I guess, that we're going to learn over the next few lessons is, well, what if we have something, let's say, a little bit more complicated, what's an example? Say 2 plus 3x, and we want to put that to the power of 4. How on earth would we do that? Now, obviously, there's a long way that we could go about and work that out, but is there a faster way? And yes, there is, and that's what we're going to investigate today. Alright, okay. Let's start by looking at a very simple expansion. Okay. Let's say we have 1 plus x. Oh, that's horrible. I'm going to do that again. Okay, let's do that again. 1 plus x, and we'll do this to the power of 1. Well, obviously our answer is going to be 1 plus x. Okay, so far so good. Why don't we now try 1 plus x all squared? And for this one, we're going to have 1 plus 2x plus x squared. If you're a little bit unsure of that, you may want to go back over your IG work, or you could put the double brackets and then use FOIL. Okay, let's move on. Whoops, come here. Let's try doing 1 plus x to the power of 3. Well, this is this here, we've just done 1 plus x squared, so all we're going to do is we're going to times that by 1 plus x, okay? So first I'll times it all by 1, so that'll be 1 plus 2x plus x to the power of 2, okay? So I've times all of x, 1 plus x squared, I've times that all by 1, now I'm going to times it all by x. So I'll do that down here on the next line. So I'll have x times 1, which is x. Then I'll have x times 2x, which is 2x squared. And then I'll have x times x squared, which is x cubed. And we can simplify this, can't we? Now, if you're a little confused as to how I've done this, think for a moment. To get 1 plus x cubed, I'm going 1 plus x, and then I'm timesing it by 1 plus 2x plus x squared. And I've just timesed all of those by 1. That's given me this top line here, and then I've timesed them all by x, which has given me this. Okay, now when we simplify this, you can see that we've got 1 plus 3x plus 3x squared plus x cubed. So I'm just going to rub that out and put it all on one line. So it'll be 1 plus 3x plus 3x cubed plus 3x squared plus x cubed. Okay, good, so far so good. Now let's try the same thing. We want to move now to 1 plus x to the power of 4. So what we're going to do is we're going to take this here. So I'll write, and we're going to times that by 1 plus x. 1 plus x, and we're going to times 1 plus 3x plus 3x squared plus x cubed by this. So obviously the first line we're going to have 1 plus 3x plus 3x squared plus x cubed. That's when I times all of those terms in the second bracket by 1, and then we times them all by x. So I'll put this on the second line and you'll see why. X times 1 is x. X times 3x is 3x squared. You see they're just going to make it easier to add. X plus 3x squared is 3x cubed, and then x times x to the power of 4 is, x to the power of 3 is x to the power of 4. Now when we add that up, we can chuck them over here. We've got 1 plus 4x plus 6x squared plus 4x cubed plus x to the power of 4. Okay, brilliant. Now, I'll clear a bit of space over here. Let's try one more, shall we? Let's try one more. Okay, let's now move on to 1 plus x to the power of 5. What is that going to be? Well, we're going to take all of this here, what we got for 1 plus x all to the power of 4, and we're going to times it by 1 plus x. So it'll look something like this. 1 plus x all into 1 plus 4x plus 6x squared plus 4x cubed plus x to the power of 4. That's a 4. Let's just fix that up. Well, let's mess it up, shall we? Okay. Delete that here. Okay. Alright, x to the power of 4. Put a bracket here. And again, as before, I'm going to do my first line is just going to be a repeat because I'm timesing by 1. So 1 plus 4x plus 6x squared plus 4x cubed plus x to the power of 4. And then we're going to multiply all of those second bracket terms by x. So we'll have plus x plus 4x squared plus 6x cubed plus 4x to the 4 plus x to the power of 5. Then when we add all of those together, we get this. 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the 4 plus x to the power of 5. Okay, now we're going to have a look at what we have done here and see if we can sense a little bit of a pattern going on. So, here our terms are, oh goodness, 1 and 1. So we'll go 1 and 1. Here our terms are 1, 2, 1. So it's 1, 2, 1. Here we've got 1, 3, 3, 1. So we've got 1, 3, 3, 1. And here we've got 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. And then we've got 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. Okay, so you see this pattern here. And hopefully if you look at this, this is Pascal's triangle, by the way. This is what we're talking about. Okay, so 1 plus 1 is 2. You'll always have 1s on the outside. And that makes sense because if you've got a whole line of brackets, say 1 plus x into 1 plus x into 1 plus x, you see that you could always get 1 times 1 times 1, and that would be your term without x's. And at the other end, you're going to have x times x times x, which will give you your highest power of x cubed. So you can see you can have those 1s on the outside. Okay, but look at how the middles work. 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 3 is 6, or 3 plus 1 is 4. 4 plus 6 is 10, or 4 plus 1 is 5. So we could make a little bit of a prediction here, and if you are watching this, you might want to stop the video at this point and see if you can predict what our answer would be for if we went to x to the power of 1 plus x to the power of 6. So pause the video. 1, 6, 15. So 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1, 6. And then have a 1 on the end. Okay, so this is in fact what you do see when you are expanding brackets like this. So let me just clear a bit of space here, and we'll write what we'd get if we expanded 1 plus x to the 6. It would look like this line here. 1 plus 6x plus 15x squared plus 20x cubed plus 15x plus x to the 4, 6x to the 5 plus 1x to the power of 6. Now, I probably have not really helped myself here. I should probably move this around a little bit. Alright, we're ready to continue on. I've got this purple and red writing here. It looks pretty confusing at first, but this will help show you the power of binomial expansion using this method with Pascal's triangle here, and we'll extend it over the coming days. So let's see if we can figure out what I've got this written here for. You know when you've got 1 plus x and you put it to the power of 1, you've got 1, a term without x, and then you've got your x to the power of 1 term. So what we've got here is 1 to the power of 1 times x to the power of 0 plus 1 to the power of 0 times x to the power of 1, and that's 1 plus x. Let's move on. Now, you know when you go 1 plus x all squared, you've got 1 plus 2x plus x squared. Notice how the first term has no x's, and the last term is just your x times x. Okay, so and the middle term is you've got your x's and your 2 here. Now this is represented by our Pascal's triangle, 1, 2, 1. But we can think of it like this. The first term is going to be 1 squared because it's 1 in the first bracket. So if we were to maybe just write this here, say 1 plus x into 1 plus x. You see that that first term is made up of 1 squared, and then your last term is made up of x squared, and your middle term, you're going to get that 2x because you've got, let's see, this one here and this one here. Okay, and that's just going to be to the power of 1. So you can see you're going up in powers of x. Now, let's go back over here and see what we've got. Well, 1 squared times x to the 0, because that first term has no x's in it. The next one, we drop our power of 1 down to 1 to the power of 1, and we raise our power of x to the power of 1. But we're going to times it by 2 because of this 2 in Pascal's triangle. So it will be 2 times 1 times x, which gives us the 2x term. And the last term is going to be 1 to the power of 0 and x to the power of 2. Now what you can see is going on here is your first term is the number 1 raised to the highest power of the bracket, and then that one drops down 1 for each term until it gets to the power of 0. So 1 to the power of 2, 1 to the power of 1, 1 to the power of 0. And the x value, or your second term in the bracket, goes from to the power of 0, 1, until you get to the power outside the bracket. And then the only other thing is we've got these red numbers here. And the red numbers, all we're doing with those is timesing. So I could go through and say that's 1 times, and that's 1 times. And all of these ones on the outside here, 1 times, 1 times, 1 times, etc. I think you get the idea. But since 1 times anything is just 1, I'm just going to leave that. But these ones that I've just added in represent the outsides of our Pascal triangle. So I'm just going to take them out because it makes it a little bit more confusing and hard to see what's going on. So I'll just pop them out now. Okay, let's look at when we're dealing with 1 plus x to the power of 3. Well, you know we're going to get these terms. We've got 1, then we've got a 3x, we've got a 3x squared, and we've got an x cubed. Again, notice the first term has no x's. The next is x to the power of 1, x to the power of 2, x to the power of 3. Let's see if we can see what's going on here. Well, 1 to the power of 3, x to the power of 0. Next term, we're going to take this 3 from the Pascal's triangle and multiply it by 1 to the power of, drop it down from 3 to 2. X comes up from 0 to x to the power of 1. That will give us our 3x term over here. The next one, again, we're using this 3. 1 has dropped down from 2 to the power of, so it's now to the power of 1. And x has gone up from x to the power of 1 to x to the power of 2. So you get 3x squared, which is what we have here. The last term, which is going to be x cubed, we're using this one here. So 1 times, and now our 1 is, we've gone 3, 2, 1, now to the power of 0. And x has moved up to the power of 3. Next line. Well, we've got terms from 1, then 4x, then 6x squared, then 4x cubed, then x to the power of 4. You see the x is going up in powers. So we can represent that as this. 1 to the power of, well, 4, which is the highest power here, and at the outside of the bracket. X is going to be to the power of 0. Then we take this 4 in our Pascal triangle and put it at the front. 4 times 1 cubed. We've dropped from 4 to 3. And now our x to the power of 0 is raised to x to the power of 1. And that will give us our 4x term. The next one is going to be, we're going to take the 6 from Pascal's triangle. 1 has gone down to the power of 2 from 3. X is going up from x to the power of 1 to x squared. And that's 6x squared term. Now, we're using this 4. And we're dropping our 1 down to the power of 1 this time. So 1 to the 1. And our x power is raised, so it goes to x to the x cubed, so we end up with 4x cubed. Look, this is perfect. The last one, we're timesing by 1, so I'm just leaving that out. 1 is now to the power of 0, and x is now to the power of 4. And we can repeat this process. So, why don't you pause the video now, have a look at what I've done for the 1 plus x all to the power of 5 line. Have a look at how that works, and then see if you can, on your own, figure out how to do this last line here using this part of Pascal's triangle when we're doing 1 plus x all to the power of 6. Pause the video now. Well, let's hope that you managed to have a go at that. Here's my answer here. Let's have a look. The first term, we're to the power of 6, so 1 to the 6, x to the 0. Then the next one, we're going to use the 6 from our Pascal triangle, 6 times. Now, a 1 to the power of, we drop down to 1 to the 5. X raises from 0 to the 0 up to x to the 1. And then next term, we're going to use this 15 here from Pascal's triangle. And we're going to have 1 to the power of 4, we've dropped down again, and x squared going up that way. And then the next term, 20 from our Pascal's triangle, 1 to the power, we're dropping down to 3, and x we're raising up to 3. And so on and so forth. I hope that's making sense for you. You might be thinking, well, big deal, how is this helpful? Well, we're going to now demonstrate how helpful it actually is. Okay guys, so we have this equation here, 2 plus x all to the power of 4, and we are wanting to expand this, and we're going to use our logic and apply what we learnt from this part of Pascal's triangle. So let's try that now. Okay, our first term is going to be, well, in this case, you notice that we're not dealing with 1 plus x, we're dealing with 2 plus x. So my first term is going to be 2 to the power of 4 x to the power of 0. And I think you can probably see why that is, because 2 plus x to the power of 4 is this, right? 2 plus x into 2 plus x into 2 plus x into 2 plus x. And you can see that when you expand that out, 2 times 2 times 2 times 2 is going to give you, or 2 to the power of 4 is going to give you your term without the x's, right? So that's our first term. Now, our second term, we're going to use this 4. So it'll be times 4. No, I'm going to do that in red, I think. Let's do that in red, times 4. And what's going to happen to our 2? It's going to be now 2 to the power of, we drop down to a 3, and our x term is x to the power of 1. Now our third term, we're going to times it by 6 first, looking at our Pascal's triangle, 6. And, well, our 2 is going to be 2 to the power of, we're dropping down 1 more to 2. And our x power is going to raise to x squared. Now, our next term, looking at your Pascal's triangle, we're moving along to the fourth number, which is 4. So 1, 4, 6, 4. And this one is going to be 2, and your power will be 1, and your x power will be raised to 3. And now you're on your last term, which you can see would be x times x times x times x. This is going to be 2 to the power of 0 times x to the power of 4. At this point, we could simplify this. That's what we're going to do. Alright, so the first term, we have 2 to the power of 4. What is 2 to the power of 4? 2 to the power of 4 is 16, 2 times 2 times 2 times 2. Our next term is 4 times 2 cubed. 2 cubed is 8. 4 times 2 is 4 times 8. Well, 2 cubed is 4 8, so 32. So this should be, hang on, 2 times 2 times 2. Yeah, 4 times 8 is 32. So our next one is 32x. And our next one, we've got 6 times 2 times 2, that's 6 times 4, which is 24. So this will be 24x squared. Our next one will be 4 times 2, which is 8. And that will be x cubed. And our last term will be 2 to the power of 0, which is 1, so just x to the power of 4. And that is our expansion of 2 plus x to the power of 4. Well, let's try one from our exercise book, and for that we're going to do this one here. 2 plus 3x all to the power of 4. Same kind of scenario here, but what has changed this time? You will notice that we have a 3x. So it's going to be pretty much the same as what we've just done here. It will be pretty much the same as this, but we will now be replacing our x with 3x. So let's look at that now. It will be 2 to the power of 4, x to the power of 0. Now, since we're dealing with to the power of 4, we're using the same line of our Pascal triangle here. So our next term is going to be 4. So it'll be plus 4, and then we'll have 2, again to the power of 3. But the difference here is that we're 3x. And I'll put a bracket around this, to the power of 1. Sorry, I should have had a 3x in this first term here as well. 3x all to the power of 0. Sorry about that. Our next term is going to be 6, because we're on the third item of the Pascal's triangle here. 1, 4, 6. So 6 is the third one. And this time we're going to have 2 to the power of, you see it drops down again, and our 3x is now to the power of 2. Right, next term, we're going to have that big 4 again, looking at the Pascal triangle, and we're going to have 2, but this time it's just 2 to the power of 1, and our 3x is now to the power of 3. And that leads us to our last term, which is 2 to the power of 0 into 3x to the power of 4. And now we're in a position to work out what this all is. So 2 to the power of 4 is 16, and 16 times 3. Oh no, it's just 16 because 3x to the power of 0 is 1. Okay, so we got 16 as our first term. The next one is 4 times 2 cubed. 2 cubed is 8, 4 times 8 is 32, and then we're timesing that by 3x. 32 times 3x is 96x. Now the next one's going to get a bit tricky, isn't it? 6 times 2 squared. 2 squared is 4. 6 times 4 is 24, and then we're going to times 24 by 9 because 3x squared is 9. 3x all squared is 9x squared. So 24 times 9, and I'm getting to 16. Oh, I should have done that in my head, really. Never mind. Okay, our next term, we've got 4 times 2, which is 8, and then we've got 8 times 27, which is also, is that right? Yeah, 3 times 3 is 9, yeah. 4 times 2 is 8, and then 3 cubed is 9. So this will be 216x cubed. And then our final one will be 2 to the power of 0, which is 1, and 3 to the power of 4 is 81. So this will be 81x to the power of 4. Okay, the last thing we're going to do is, I'll just scroll down a little bit further, and we are going to do question 3. And in question 3 from your text, you need to find the last 3 terms of 4 plus x. The last 3 terms. Now, how are we going to find the last 3 terms? Well, hopefully you can see that we're going to use this part of our Pascal triangle. And since we're looking at the last 3 terms, you can also see that we want to look at these ones here, the 15, the 6, and the 1. So I'm going to go ... because we're representing the ones that we're missing out. The last 3 terms. We've got a 15, we got a 6 times something, and we got a 1 times something. You could leave the 1 out like I have been doing. I'll just leave it in since I've written it now. Okay, let's think about our last term in this series. We know that our 4, the first term in our bracket, over here, we know that that is going to be to the power of 0. And we know that our second term in the bracket is going to be to the power of 6. Okay, just like we've got up here, but we're just complicating it by having a 4 instead of a 1. Let's go back to the previous term. Oh dear. Okay, the previous term, there we go, is going to be 6. Now our 4 is not to the power of 1, 0 will be to the power of 1, and our x will be to the power of 5. And then the term before that, we're going to have 4, it'll be to the power of 2, and our x will be to the power of 4. Alright, and then, what are those terms? 15 times 16 is 240, so that will be 240 x to the 4. 6 times 4 is 24, so the next one will be 24x to the power of 5, and the final one will be 4 to the power of 0 is 1, so it's just going to be x to the power of 6. And that is your answer to that question. Well, I hope you are able to do a few of the questions from exercise 6.1 as a result of this. Look, there may be some questions that you need to clarify, and feel free to do that by emailing me, getting in contact with me. I'm totally happy to help. But if you are stuck, maybe watch the video a couple of times, because this took me, when I first did it, a few times to get the hang of. Alright then guys,